Hello everyone and welcome to Atoms Part 2 from Science Simulations, in which we will be talking about types of atoms as neutrals or ions. Also, we will discuss how atoms can be stable or unstable. Then we will learn about isotopes, and at the end we will discuss forces in the atoms. So let's start. Now let's explore how do we know if an atom is a neutral atom or an ion. So let's come back to the original state. We have nothing. So when we have one proton and one neutron and one electron, this is a hydrogen atom and it's a neutral atom. Why does it say neutral? Because remember I told you the charges of protons are positive and the charges of electrons are negative. So you have one positively charged particle, which is the proton, and one negatively charged particle, which is the electron. So 1 plus 1 and negative 1, they cancel each other, and that's 0. So the charge of the whole atom all together is 0. So it's a neutral atom. Atoms tend to be neutral most of the time, but sometimes you get something called an ion. What is an ion? If you have more protons than the electron, you have a positive ion, because you have a positively charged particle in the middle here, but you don't have any negative one, so it's not a neutral atom, it's a positive ion. And if I add more electrons, for example, you have 2 electrons and 1 proton, that's a negative ion. If you have 3, it's still negative ion. If you have 4, it's still negative ion. But how can you tell how many electrons more you have than the proton, or vice versa? This is where you can see the net charge. If the number is -3, that means it has 3 more electrons than the proton. So +1 and -4 is -3. So this one is cancelled out with this one, but then you have 3 more electrons, that's why it's -3. What if I have 2 electrons and 5 protons? So can you guess what is the net charge? Of course you can say it's a positive ion because the positively charged particles are more, but what is the net charge? So let's see. If you have 1, 2, they will be cancelled with these 2 and then it will be neutral, but then you have 3 more, so you can say +5 and -2, so the net charge is going to be +3. This is how you can test the net charge. So we explored how atoms can be modeled, we explored the mass number and the atomic number, and the net charge. Now let's see, what do we mean by stable or unstable? Of course you can hide the element name, you can show if it's neutral or ion, and now I can show if it's stable or not. So let's reset and let's start. If I have 1 proton, this is an atom of hydrogen. Hydrogen is the lightest element because it has only 1 proton. There are no other atom has only 1 proton. This is unique to hydrogen. And you can see it's a positive ion, so I'm going to add 1 electron to make it a neutral atom. Now, hydrogen is stable. If I add a neutron, it's still stable. But if I add 2 neutrons, it's going to be unstable. So some atoms can be stable, some can't. And you can think about it, the more mass you have in the nucleus, the more likely your atoms to be unstable. So if I have only 1 proton, it's a hydrogen atom and it's stable. If you have 1 neutron, it's also stable. But if you have 3, it's going to be unstable. So does that mean hydrogen only have 1 proton, or does it have 1 neutron as well? Well, it's both. So we have something called isotopes. Isotopes are like version of hydrogen. So we have hydrogen 1, which only contain 1 proton, so the mass number is 1. You have hydrogen 2, which contains two particles in the nucleus, one proton, one neutron, and you have hydrogen 3, but this one is unstable, so it's not that common. So when you have many particles here of protons and neutrons in the middle, it's more likely to be unstable. So let's see this. If I have two protons and two neutrons, that's stable. If I add another, it's unstable helium atom. So helium can have only one neutron, it can be stable. It can have two and it's still stable, but when I add the third one, it's unstable. Let's look at lithium. It has 3 protons and 3 neutrons, and that's stable. When I add more, it's still stable. But when I add 5, now it's unstable atom. Some of you might ask a question about the forces between these particles. So if I have electrons, which are negatively charged particles, and protons, since they are having opposite charges, they will attract, and that's what keeps electrons in orbit around the nucleus, because the nucleus has positively charged particles, which are the protons, and neutral neutrons. So the total charge of the nucleus is positive, and when you have electrons which are negatively charged, they will be attracted, and that's what makes them orbit the nucleus. But what about the nucleus itself? What kind of forces do we have in the nucleus? First of all, you can think about, hey, don't protons and protons have the same charge, so they should repel each other? That's correct. There is a repulsive force between these protons. So what makes this stable? What makes this stable is the number of the neutrons related to the number of protons, because there is a strong nuclear force which is called the strong interaction. This is way stronger than the repulsive force. This is the force that keeps neutrons and protons in the nucleus. So there is a big attraction between neutrons and the protons, and this force is way much stronger than the force of repulsion between the protons. That's it for this video about atoms. Wait for the third and final part soon, in which we will talk about how the periodic table is ordered and element cards, and we will end this simulation with a game. See you soon. Pandabood.